Good morning, good afternoon, good evening, whenever you may be. It's time for another exciting lesson in 7th grade science here at 8th grade ACE Academy. So I hope you guys are being safe wherever you are, and I know I am here in the Brenna bunker. Happily quarantined here in the Southeast United States. Let's spend another day learning about some 7th grade science. So yesterday we talked about the water cycle and how important that was to everything going on as far as weather, getting that water vapor into the atmosphere pretty much is what produces the weather, and the fact that we have, wow, excuse me, the ability to, have, crops and farms and live, away from, water sources is, the only way we could do that was because of uh, weather and its ability to transport water around places. But we're going to move on. So today we're talking about air pressure. So air pressure is like, I can, here's your statement. It says, I can explain what air pressure is. Well, first we got to do, what is air pressure? So air pressure is simply the mass of the column of gas above the measuring point is affected by gravity. So we go down here, here's a visual of this. So way down here on the surface of the earth, there's where we're standing. And then extending above you, it says right here, area 1 inch squared, an inch by an inch by an inch, just a square that's, inch on each side, goes all the way up. This is the column of air that sits above you. And this one here is divided into the, the different layers of the atmosphere. So remember that gases are composed of atoms and atoms have mass. The gravity of Earth acts on this mass to give those molecules weight. This weight of the molecules of the gaseous atmosphere is known as atmospheric pressure. So again, here's that column of air. Air is made up of molecules of gas. Those molecules have mass, and the gravity of the Earth pulls that mass down, giving it weight. Yeah, individually, each molecule doesn't weigh much, but when you got a column that's 310 miles high above your head, it actually gains some actual weight. So this entire column over the square inch ends up weighing 14.7 pounds in that square inch. That is our standard atmospheric pressure. In the United States, we measure it in pounds per square inch. Other places, they measure it in millibars, which is the metric. You go to aviation or in shipping, they measure it in inches of mercury, which 30 point something, 29 point something inches of mercury as a really old designation for a barometer measurement. So you could hear it either way. You could have your PSI, you could hear it in millibars, or you could hear it in inches of mercury. So the way this molecules of gaseous atmosphere is known as the atmospheric pressure. So there's right there is your definition of atmospheric pressure. Now, day to day, this pressure changes by a small amount. It varies with temperature, wind velocity, and the actual gaseous composition of the molecules in the column above you. What do you mean varies with that? We'll talk about that particular part of it tomorrow, but the variation is not a whole lot. If we're on a beach next to the ocean, we have approximately 80 kilometers of gas above us. When you take measurements at 0 feet of altitude, it's called mean sea level, or MSL. So right there at the beach, you are at sea level. Literally, there's the water. That's the level the water's at. And think about it. And since we all do not live over our beach, our pressure measurements are adjusted for what they would be at mean sea level. So even though you live away from the beach, we live, here in Charlotte, we're, about 730 feet or 222 meters above sea level. So, but yet our pressure measurements are still given to us like we were at sea level, so that we can make our adjustments to, and understand what the weather is going to be. Because if you didn't adjust it, then, you would have no idea. Well, 30.02 at one place would be good weather, and 30.02 at another place would mean horrible weather. So they adjust it all based on your altitude, like, and they read it to you like you're at mean sea level. So as you walk away from the water's edge of the beach, how you would describe that walk? It is a flat nope, you're walking uphill. As you get away from the water, you get higher gain altitude. Like I said, so here in Charlotte, we're about 222 meters above sea level. So that means we have 222 meters less atmosphere over our heads than they do at the beach. Less column height means fewer molecules, which means less mass, which means less weight. So the air mass might be the same one at the beach as sitting here, because I mean, you may only be, we're only a couple hundred miles, not even a couple hundred miles from the beach, and the same air mass may actually be sitting over us. And again, we'll talk about air mass a little bit later. So the pressure would be basically the same across the mass that we're in between here and there. But yet, if we just took a actual reading of the way the molecules above us, because we're higher, it would be less. But again, the weather, they correct it for sea level so that everybody can have an understanding of what the pressure is that is relevant to the weather. Now, if we go ahead and travel up in the mountains, we gain more altitude. Say we travel to Santa Fe, New Mexico. We go out to Santa Fe, New Mexico. It's a very large city out west. It happens to be located in a river valley between a couple of mountains, but it is still 2.2 kilometers above sea level. Excuse me. That's pretty far, 2,200 meters. So here in Charlotte, we're 222 meters. They're 2,200 meters above sea level. As the lowest, so that's pretty high. So as the lowest level of the atmosphere is also the most dense, but again, gravity pulls those molecules down. You're going to find more of them at the bottom than at the top of that column because of the effect of gravity and pulling them down. So the densest air, where the most air molecules are, and thereby the most mass of air molecules, is at sea level. And as you go higher, air pressure changes very quickly. So at the lowest level of the atmosphere, it's also the most dense. A seemingly small change in the height versus a more profound change in atmospheric pressure. So going from sea level to Santa Fe, 2.2 kilometers, that's only a 3% change in altitude, 80 kilometers versus 77.8, but leads to a 23% reduction in atmospheric pressure. In fact, by the time we hit 5.5 kilometers of altitude, the air pressure has dropped to half of what it was at sea level. So 80 kilometers is the whole thing. But by the time we go 5.5 kilometers into it, so say 6%, 7% maybe, up the column, we've lost half our air pressure. So this small change in altitude leading to such a drastic change in air pressure really drives home how dense the atmosphere is at its lowest levels. Even though we say the atmosphere extends to 80 kilometers, remember talking about structure of the atmosphere yesterday or the other day, it goes to 10,000 kilometers, right, before it hits the solar wind. But effectively, where molecules of atmosphere are that are we consider truly an atmosphere, 80 kilometers is about the top of it. The majority of the molecules that we consider atmosphere occur within the first 20 kilometers above the ground. After that, there's still gas molecules present, but they're not in the numbers we would consider an atmosphere. Above 20 kilometers, I mean, gas molecules can travel over a kilometer before they hit another gas molecule. That's a lot, when you're considering that's how few, how far apart the atoms are. So, I mean, they're still there. There's just not that many. Okay, here, look at this again. So here's our column of air from 0 to 10. And, the stratosphere, the mesosphere, the thermosphere. And when you get to the top of the thermosphere, the air pressure has reached 0 psi. Here's another way of laying it out. So down here in the troposphere, which is where all the the weather takes place, standard pressure is about 1,000, somewhere around 1,000 millibars. There's that metric system using measurements. So as you go up, here comes your pressure drop. So by the time you hit 10 kilometers, the end of the tropopause or so, your pressure's down to 230, 240 millibars. That's not much. Get up there to where that airplane's flying, that Boeing 747 above in the stratosphere, it's below 200 millibars. And man, it really starts, that curve starts steepening up as you get up there and into out, 20 kilometers, you're down to less than 100 millibars. And it, runs into, gets to the point where it's really sparse up in here. So basic lesson on air pressure, just, effectively what it is. So I can explain what air pressure is. Air pressure is the weight of the molecules of the gaseous atmosphere that is above you at that point. So if you're higher in altitude, your air pressure will be lower. Guys, for those of you that follow football at all, think, Denver, Mile High Stadium, right? Mile High, 5,000 some odd feet. It's tough to go up there and play a sport, is because, again, at 5.5 kilometers, mile is 2.2 kilometers is a mile. So you have 23% less atmosphere to breathe playing in Denver as you do down at sea level, or Charlotte, 222 meters, not 2,200. So there, you're playing with a lot less atmosphere to get your oxygen in and out. And so a lot of the sports people tell you, yeah, it's tough to go up there and play. Then if you do something like skiing and go even further up into the mountains, go into, say, Vail, Colorado, which is even higher up in the mountains than Denver, it takes a lot of energy and a lot of breathing to supply yourself with the energy to go ski, because of how far up into the atmosphere you are. You're, seriously, depleted in your capability of getting oxygen when you get that high. So those are the kind of things that, that's what it means for you. So if you have any questions or anything, please, drop me a line. Hit me up on my cell, 704-363-9034. If you have any questions, that's the fastest way to get me and to make sure you actually get a response. Please, again, sign in, say hi down in the comment section. That's your attendance for today. And then like the video and sign up for the, for my channel. So hope you guys have a great rest of your day. Make sure you do your do now questions, and we'll catch up with you later.